Hey people, welcome back. In today's session, we are going to learn about how to calculate the sigma level of the process when your specification lower is better. Still, we are talking about the one-sided specification only. Lower is better. Example for the when you will see something out of a process is lower is better, like as defect. Maybe your average handling time, maybe your cycle time of any process, maybe complaints, maybe market return. These are the things are always we consider as in lower is better. So the formula we use for the lower is better because you have the specification lower is better. That means any value is lower side as low as possible will be good for us. Then the limit will have, we will have the USL or upper specification limit, which means any value should not cross the upper specification limit what we are deciding, otherwise lower is better. Let us take an example of AHT. If AHT, suppose my upper specification limit is let's say 5 minutes. Any of the transaction which I am working on should not be crossing the 5 minutes. I have some data collected, random data, and my random data is maybe ranging minimum from 2 minutes to let's say 8 minutes. So adding decimal here by this formula, and this is your data. Suppose you have collected the data. This is for last 30 sample. Good enough to understand 30 sample data we have for the AHT. And I wanted to find out when my specification lower is better and my upper specification limit is 5. So as per this data, what is my sigma level of the process? So let us understand this concept first. What does it practically mean? Suppose this data will come as a distribution. Maybe assume this data distribution is coming from lower side. This is the minimum value. Here is your central value, almost average, and this is your maximum value. Out of this, I am looking for that average AHT or any AHT should not be greater than 5. So suppose if should not be greater than 5, maybe my actual value is coming somewhere here. This is your value of 5. So now if we look at this, changing the color to orange line. So what we see in this, because this is your upper specification limit, any value lower is better. So the percentage of data out of total 100%, whatever is less than this data is a good quality, which means this is meeting your specification, and the value which is going outside this on the right hand side, this is not meeting the specification. So out of 100%, we will be calculating how much percent data is meeting. That is your data is, which means it is a part of your good, and any data which is not meeting the specification on the right hand side of the orange line, this is your defect data. So basis on the quality data which is on the left hand side, or 100% minus defect data, will become your yield, and we can easily convert yield into the sigma level, right? So first let's find out the sigma. What is the sigma of this? So when you have the upper specification limit, so the formula for sigma will work is equal to your upper specification limit, because that's what we have, minus average value, and you are going to divide this by the standard deviation. So for this, I need standard deviation, I need USL, which I already have, and I need the average value. So just shifting this little bit right side, here I am calculating the average of the data, and here is my standard deviation of the process. Now, average, you know, formula is equal to average, selecting your data. So my average AHT is 5.09, where my target is 5, which means my on an average is higher than the target, which means I have more than 50% of the chance that my defect are higher than the 50% basically based on that, because this value is, if it is exactly difference is 0, then it is 50%. If difference is less than 50%, less than 0, then my value will be more than 50%, because my yield is here, average is greater than the target when my lower is better. So this value is crossing the 5. This means I have less than 50% yield here. Let's calculate. We will be calculating in the form of standard deviation as in variation. Now, if I put these three value into the formula of sigma, so is equal to USL is how much you are looking for? 5 minus average value 5.09 divided by standard deviation 2.08. Now here value is coming minus 0.04 sigma. If this is your sigma value, so what will be my yield percentage? You can convert this sigma value into the yield percentage. So yield will be is equal to, using the formula norm as dist, selecting this value. This is around 48% yield. So as I was telling before, if your average value when specification is lower is better, is crossing the upper specification value, then it will be negative. Negative means less than 50%. So you see negative 0.04. That's how we got around 48%, which means there is a chance how much? Defect is equal to 1 minus yield, which means approximately 51.74% of the time, as per this data, I will be missing the limit or upper specification limit as in 5. That's how we calculate the sigma level when specification lower is better and you have the upper specification limit. Thank you so much. I will see you in the next session when I will be explaining you about how to calculate the sigma level of a process when you have both the side specification, which means you are looking for the nominal value. You have upper as well as lower specification limit. Thank you so much.